Hey guys, in this video we're going to be doing 1B.3 and our master learning objective is being able to convert an expression from radical to rational exponent form to radical form by simplifying the expression using properties of exponents. So we're going to be multiplying these next couple of examples, and don't forget that we're going to still be using all those exponent rules that we were doing in Target 8, right? When we're multiplying bases, we add our exponents. When we are dividing like bases, we're going to subtract them. When we have a power on the outside of our parentheses, we're going to be multiplying our exponents. So all those properties that we were just doing, we are going to be doing in these videos. So looking at our first example, we have 6x to the fifth times 7x to the 1/2 power. So the first thing that we're going to do is we're going to go ahead and take out those coefficients and bring those out to the front. So I'm going to have 6. Don't forget we're multiplying all these terms here. So we're going to times 7. Oh, I lost my pen. Times 7. And then I'm going to also multiply my x's. Right? When I have x to the fifth, and I'm multiplying that by x to the 1/2. Since you are multiplying like bases, we are going to add those exponents. Alright, we can go ahead and simplify that a little bit more. 6 times 7 here is going to be 42. And x raised to, if we have 5 plus 1/2. Yes, you could go ahead and plug that in your calculator. Those of you that want to see that done by hand. You also have an option. You can kind of do it on the side. That's fine. We have 5/1 plus 1/2. You need to make sure that those denominators are the same. So I got to change this denominator to be a 2. So if I do that, I need to multiply 5/1 by 2/2. And when I multiply that out, that's going to give me 10/2. And now that my fractions have the same denominators, I can go ahead and just add those. So this is going to be 11/2. Again, you don't have to do that by hand. You can also just go ahead and plug that in your calculator, whichever you choose. Now, the one thing that you can't forget to do is that my answer is not complete. I still have to rewrite this in radical form. So now remember that this 42 has its own exponent of a 1. In the previous video, we only rewrite bases that have exponents as fractions inside of our radical symbol. So my 42 has an exponent of a 1. That is a whole number. I'm going to write 42 then on the outside of my radical. My x to the 11/2 is a fraction. So my base of x has to go inside the radical. My numerator of 11 is my exponent, and the denominator is my root number. Now I am done, and this is my final answer. So once you simplify it, that's only part of it. You still have to go ahead and rewrite it in radical form. In example 2. I'm going to bring out my coefficients again to the front, so I have 6 times 2. And then I have my x's as well. Those are like bases, and when I am multiplying, I have to add the exponents. So I'm going to have 7/4 plus 4. When I multiply 6 times 2, that gives me 12. Bring down my base of x, and I have to add 7/4. So again, yes, you can use your calculator. If you want to see it done by hand, you probably are going to change our denominator to become a 4. Right, like denominators, this is going to stay 7/4. If I change my second fraction to have a denominator of 4, I do need to multiply top and bottom by 4. So this is going to give me 16. And for my numerator, I'm going to have 7 plus 16, which is 23. And then my denominator stays the same as before. So that is going to be my exponent for my x, 23/4. I'm not done yet. I still have to write my answer in radical form. I know my 12 has a exponent of a 1 because of the fact that 12 and x are not in parentheses. They're not grouped together. So my 12 is going to be outside of my radical. My x is going to be inside of the radical. My numerator is going to be 23, and my root number is going to be 4. Okay, moving on to example 3. Example 3 is involving the quotient rule. So when we're dividing, we have to remember to not only divide our coefficients, but when we're dividing our like bases, we have to subtract our exponents. So I'm going to go ahead and draw my fraction bar, so it's kind of easier to have everything where it needs to be. So I'm going to have 4 divided by 2, and then I'm going to have x to my 5/3 power. And I'm going to go ahead and subtract 1/3 from that, because since I am dividing these like terms, I use the quotient rule, so I subtract them. So that's going to give me, well, 4 divided by 2 is 2, x, and if I have 5/3 minus 1/3, they already have like denominators. So I just have to subtract the top. So 5 minus 1 is 4, and my denominator is 3. Again, don't forget you still have to write this in radical form. So this over here, if I have my radical form, that 2 is not in parentheses. With the x, it's not attached to it. It has its own exponent. So don't forget to give it its own power of 1. That's a whole number, so it's going to stay outside. And anything with a fractional exponent or a rational exponent is going to be inside the radical. So that x is going to be inside the radical. The numerator of a 4 is going to be my exponent. And that denominator of a 3 is my root number. Looking at example number 4. Same idea as the one we just did. We're going to have 15 over 3. And we have like terms of x to the 1/2 and x to the 1/10 power. And we're going to go ahead and subtract these because we are dividing. So 1/2 minus 1/10. Yes, we can go ahead and do this by hand. Like I said, you can go ahead and do it on the calculator if you so choose. That is your choice. But again, to show you by hand, if we have 1/2 minus 1/10, we need those like bases. So I'm going to go ahead and change that first fraction to have a denominator of a 10, which means I'm multiplying both top and bottom by 5. So 5 over 10 minus 1 over 10. Now my denominators are the same. I know that's not going to change. And 5 minus 1 is 4. So that's going to be my exponent for my x. So I have x to the 4/10. Oh, and actually, I can simplify that even more. So let me simplify that. Oh, there's my eraser. I'm going to go ahead and simplify that. Because 4 over 10 can simplify if I divide both top and bottom by 2. That becomes 2 over 5. And that's actually going to be my exponent. So always remember to simplify your fractions to be as simplified as possible, and then go ahead and finish off your question. To finish this off, I have to divide my coefficients. So 15 divided by 3 is 5. I'm going to rewrite this as a radical. 5 has its own exponent of a 1. That is not a fraction, so that's going to stay outside of the radical. My x, however, does have a fractional exponent, so I'm going to write that base inside the radical. My exponent is a 2, and my root number is a 5. Alright, looking at our next example, example number 5. We have 81x to the 8/7, all raised to the 1/5. half or 1/4 power. So dealing with our kind of our notes from target A1, remember still that this 81 has its own little exponent of a 1. And when we have those exponents on the outside and we're distributing them in, remember that you're only multiplying them with the exponents, not the bases. So for this first one, I'm going to bring down my first base of 81. Its exponent is a 1. And I have to multiply that by 1/4. Remember, when that exponent's on the outside, you multiply those exponents. Bring down my next base, which is an x. I have a 7. Again, multiply that by 1/4. Now then I'm going to go ahead and simplify, and don't forget to write my answer in radical form. So if I have my base of 81, 1 times 1/4 is 1/4. When I have my variable x, I bring down that base. 7 times 1/4 is going to give me 2 7s. Again, and if you want to see that work done on the side, so 8 7 times 1/4. When you multiply those across, 8 times 1 is 8. 7 times 4 is 28. And then when we simplify both top and bottom, we can divide both top and bottom by 4. Right, this becomes 2 and this becomes 7. So that's going to be my exponent for my x. And now, when we do write this in radical form, I know that this has a fraction exponent, so we would think to put it inside the radical. However, we know what this base is, right? It's not unknown like this x. So if you ever know the base that you have, go ahead and just plug that into your calculator. You need to figure out what 81 raised to the 1/4 power is. So when you do that, you type in 81, use that little caret symbol, type in your 1/4, click enter, and you do get an answer of 3. So don't forget, always check that. I know we said anything with a fractional exponent goes inside the radical, but that's only true if you don't know what the base is. We knew what this base was. It wasn't 81. So when we plug that into our calculator, we get 3. And then we just bring down our x raised to the 2 7 power. Write this as a radical. So my 3 is going to stay outside. My base of x is going to go inside. I'm going to have that raised to the 2nd power. And my root is going to be a 7. Okay? And our last example here is going to be example 6. Similar to the one we just did, we have to distribute that exponent on the outside of our parentheses to every exponent inside. Keep in mind that 64 has its own exponent of a 1. Do not ever multiply exponents and bases. You don't do that. So we're going to have 64 raised to the 1st power. Since that exponent's on the outside, we multiply 1 times 1/3. Bring down my next base of x. We have 9/5 times 1/3. Simplify this as much as possible. So I'm going to have 64 raised to the 1/3 power, because 1 times 1/3 is 1/3. Over here, if I multiply these out, 9/5 times 1/3 is going to be 9/15. Those both can be divided by 3. So that's going to give me 3/5, which is my exponent for my x. Again, before you write this in radical form, notice that we have this base of 64. Yes, I know it has a fractional exponent, but you know what that base is. So go ahead and plug in into your calculator 64 raised to the 1/3 power, and that's going to give us 4. So 4 x raised to the 3/5. Again, write this in radical form. I only write the things with the fractional exponents inside. So that 4 is going to stay outside. My x inside my radical, the exponent is a 3, and my root or index number is 5. And that's the end of this video. So you can go ahead and start on 1B.3 activity.